This is Precalc 5.3 Day 2. We are solving some more equations here today, guys, with some trig functions. So,
Are you recording?
yes, this is recording. You guys can listen to your own voices later. The biggest thing about today is that we're going to continue kicking up the complexity of our problems. Yesterday we started off with some real easy ones of, hey, when does sine equal 1/2? Oh, at 30 degrees and 150 degrees. We came across this idea that there's more than one solution. Then we kicked it up by having you guys solve a small 1-2-step equation before you could solve or get rid of the sine or the cosine or tangent. Then we went into the fact that you had to take the square root of both sides to solve the equation. Today, we're going to go here with this problem, and you can see that you have a cosine on each side. Now, I think the natural thing that most of us would want to do is say, hey, couldn't I divide both sides by cosine? So if I divide both sides by cosine, they're gone. So I'm left with 2 sine of x equals the square root of 2. You divide by 2. I'm going very fast right here because this is not the right method. Now, you guys are like, wait a minute, how can this be the wrong method? I have sine of x equals square root of 2 over 2. I know that. What angle gives me a square root of 2 over 2 as sine?
35.
135 and 45. So this has how many solutions? Here, here, at 45, and then 135. And of course, if I'm looking for all solutions, it's 45 degrees plus, not 90. I got to go around, right? So I'm adding 360K. So we would visually say that's x equals 45 degrees plus 360K. You guys remember that from yesterday? We added that layer into there as well. I want to find all solutions. We'd also say 135. I'm not going to write that because I'm going to erase all of this stuff. The problem is, there's 2 more solutions. There's cosine in there. If I want to actually do this, I have to find the solutions for cosine as well. But, Mr. Konchak, cosine's gone. That's because you divided it out. So to properly do this problem, we're not going to divide it out. You're going to bring it to one side, and then you're going to factor it out. So I'm going to pause the video, bring it back to our original. Okay, now we're back to our original. Now, I said we were doing it wrong before. Not necessarily. Those answers are still going to be there. They're still important. The same process will be there. But your first initial process has to be honored. You guys, we're not going to ever cancel out trig functions. You cancel out trig functions, you lose solutions. Instead, you bring everything to one side, which means I'm going to subtract a square root of 2 cosine x from both sides. When I do that, this whole entire side will become 0. I think everybody can agree with that. The left-hand side is going to be a little bit on the longer side here. But do you guys see now what I meant by the fact that you have to, or can, factor or take something from both of those? What can you actually take from both of those? What's in both of the left-hand side? What's in there? It's a cosine. So that means take it. Factor it out. Cosine x. If I took a cosine x out of that first group, what's left? What's left in there? I understand there's only like half of you left in this room, but come on. 2 sine of x. And then I take the cosine away from that second group is left with a negative square root of 2. And all of this would equal 0. Hey, wait a minute. That's the zero product property. 2 things multiplied together that equal 0. That means one or both of these groups have to be set equal to 0. Cosine x equals 0 and 2 sine x minus the square root of 2 equals 0. Wait a minute. Didn't we just do this? Didn't we cancel out cosine from above and that's what we got? Does everybody understand, without having to show much fanfare here, that sine of x is going to equal the square root of 2 over 2? Which, again, goes back to first and second quadrant. Has a reference angle of 45. So that means x is equal to 45. X is equal to 135 plus 360k plus 360k. You guys okay with that? Now, we should possibly talk about this again. We could also call these radians, right? What would 45 degrees in radians be? How many times is 45 going to 180? 4 times, so it's pi over 4 plus 2k pi. If I'm going to 135, it's 3 of 45, so 3 pi over 4 plus 2k pi. Both of those are correct. They mean the same thing. One's in degrees and one's in radians. You guys all know that. We just solved for that before. This is still right. By dividing out, in the very, very, very beginning when we first started this, we have found half our solutions. You were half right. What we did is we lost this guy right here. Cosine x equals 0. When does cosine equal 0? This one's actually a good one. This is a nice one. Take your unit circle out. Where are they? Where would cosine equal 0? 90 up here and 270. So x equals 90. X equals 270 plus what? 360k. And of course, if we wanted to, we could claim these were in radians instead. And if I did that, we would have x equals, what's 90 degrees in radians? Pi over 2 plus 2k pi. And x, what's 270? 3 pi over 2. Thank you. 2k pi. So it's the same thing as yesterday. The only difference that we have now is the fact that you had to make sure that you are factoring so you don't lose your solutions. Okay. Next problem. Mixes cosines with sines. I'm only looking for the interval between 0 and 2 pi, so therefore I only want radians. And I don't want the 2k pi onto it. I just want the ones that are on one full revolution around the circle. Now, if we learned anything from the last problem, I can't divide, right? So I need to bring everything to one side. You guys all agree with this? Okay. But let's think about this problem. Can you guys see any connection with the fact that if I brought the sine of, or 2 sine squared x to the left, or the 1 minus cosine to the right, is there a common term that's going to be in everything? They don't both have a cosine, they both don't have sine. So at this point, even bringing it all to one side is not going to necessarily help us. So therefore, I may have to change this. Are any of those a possibility of changing to equal something else? Possibly a cosine into a sine, or a sine into a cosine. Does anybody remember Pythagorean theorems, or the Pythagorean identities? What's sine squared? Right, so sine squared plus cosine squared equals 1. So couldn't I solve that for sine squared? This is squared right here. Yes, but could I replace this piece? 1 equals sine squared x plus cosine squared x. If I took the cosine and brought it to the other side, wouldn't that equal 1 minus cosine squared? Is equal to sine squared? So I'm going to replace it. So now I'm using my identities. Bless you. I'm using my identities to change everything into cosines. Now what should I do with that 2? Probably move it in, distribute. Now if I bring everything to one side, I have all the same function, yes? Which side am I going to bring things to? Am I going to bring it to the right or to the left? And why? It won't matter, but there will be a reason why I want to do one way instead of the other. Going left or right? I'm going left. What's your squared term? It's this guy. He's got the highest power. The highest power, guys, generally you want positive. So I'm going to bring it all to the left. So I'm going to subtract 2, add 2 cosine squared x. Notice these are not the same, so you cannot combine them. But I get 2 cosine squared x minus a cosine x minus 1 equals 0.
Wait, how are they multiplied?
What's multiplied?
2 cosine squared. It's with the, oh, never mind.
Okay. Doesn't that form a quadratic? So now we're just kicking this up and we're adding this quadratic stuff into here. That needs to be solved. So the question is, can you factor that? How many people actually recognize that there's a quadratic? Okay, some people aren't. Isn't that the same thing as this? I just take out cosine x and put a u there instead. Isn't that 2u squared minus u minus 1 equals 0? If it helps, take the cosine part out. The way I officially did that is I went here and I said let u equal cosine x. If I do that, then I get this resulting polynomial. Now, a is not equal to 1. So we could do a times c, find the factors of that, split it up, factor by grouping. But 2 and 1 are pretty small numbers. I should possibly be able to come up with the combination on my own. Because 1 and 1 are the only options for the end. And 2u and u are the only options to get 2u squared, right? The only thing I have to worry about is my signs. Is it supposed to be plus plus, minus minus, a plus minus, or a minus plus? You got 4 options, right? If everything was positive, could you ever get a positive number at the end? Right? If I made these both positive inside here, could I end up with that negative 1 at the end? No. If they were both negative, I could not end up with that negative. So one of them has to be positive and one of them has to be negative. The key is the middle is negative. That means when you multiply your numbers together, they have to add up to negative 1. And And I think the only way that's going to work is if you put a plus here and a minus there. Because 2 times negative 1 is negative 2. Add the 1 back, you got negative 1. And 1 times negative 1 is negative 1. You have it factored. Now here's the thing. You don't solve for u. You solve by putting back in cosine. So this is really 2 cosine x plus 1 and cosine x minus 1 equals 0. And now you solve, how many different equations do you have to solve? You just got to solve 2, right? So here we go. When does 2 cosine x plus 1 equal 0? And when does cosine x minus 1 equal 0? Without showing too much work, would you guys agree that cosine x equals what? Bring the 1 over, divide by 2. Negative 1/2. And over here, cosine would have to equal what? Not all at once. 1. Cosine's negative where? How many places? How many places? Okay, where? What quadrants? Come on. Cosine. Negative. Second and third. What angle gives you a cosine of half? If you use a unit circle, you know it right away. If I'm looking at the fact that cosine of this angle is a half, it is 60. So the angles x, actually wait, sorry, we're not using 60, we're using what? Up here. We should be using what? Not 60, but pi over 3. So, how do I get to that first angle? X equals, it's not pi over 3, it's, how many 60s does it take to get to that spot? 2, so it's 2 pi over 3. And x is equal to 1 more than pi, so therefore you're at 4 pi over 3. There's 2 answers. This one's an easy one. When does cosine equal 1? Only there, isn't it? So, x is equal to 0. How many answers? Just 3. And you're done. So this one, we had to change it. Use a little bit of identity work. Change it, created a quadratic, factor that quadratic, solve them individually. It's good stuff. Homework for day 2 of 5.3 is page 331, 5 through 17, odds and 25. Have a great day.